object-oriented and TDD zealots are the loud minority and are too full of themselves. Fine. We are. We're too full of ourselves. But this isn't about being too full of yourself. This is about going back to the roots of what defines software. It's about going back to the roots of what defines software engineering, about what programming is about what object orientation is about, and following a series of guidelines and principles that help us write better software. It's not about some kind of ideology or being too strict or saying that if you don't follow certain guidelines you are a bad programmer or you have an unsuccessful career. It's just about going back to our roots, about revisiting some of the lessons that we forgot during our new ventures with the tools. You don't need to know design principles to write software. You don't have to know them to have a successful career. And you can write line of business applications without a single line of code. Okay? You can. It's called drag and drop. It's called dynamic data services. It's called ASP.NET Web Forms. Well, there you have to write some code. However, to create sustainable applications, it would be great if you did know a little bit of what you're doing. Okay? It would be great if you knew a little bit about design principles, about the roots concepts in object orientation. How many of you know what object orientation is? Everyone, right? It's classes, it's fields, it's methods, it's polymorphism, it's inheritance, it's composition, all these. And yet we don't seem to apply it that much. Right? Here, let me show you an example of object orientation. This is a code I downloaded from Google Code, and it's Google Analytics. Right? Basically what it does, it connects to Google Analytics and it gets information and then it tells you the statistics, etc. Okay? So let's look at it. You can already tell something's wrong, right? By the using statements. Not only that, I like to call this, if you know Resharper, this is equivalent to the WTFs of Resharper. Right? So, you know, it's already like, wow, that's a big scroll bar. Of course, we've solved that problem as well, haven't we? It's called rock scroll. They say install a little plugin here that gives you a preview of your code. No, it's why the hell you got 3,000 lines of code in a single file. So we start to scroll down. This is an object. It's got fields, it's got constant, it's got methods, it's got more methods, it's got paths, it's got SQL, it's got more stuff, it's got more methods. Right? Now this is an exaggeration, but it's not. You look through CodePlex, you look through Google Code. This is what you get. Right? Now this has an advantage. You work with a guy that writes this code and he goes on holiday and there's a bug. You know for sure where the hell the bug is. But that's about it. Right? It's like, it's in that class. Oh really? I thought it was in the assembly info. No, 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 don't look there. It's not there. But yet he's applying object orientation because he's got methods, he's got classes, he's got properties, he's got fields. This is the only slide that I'm going to come up with the word solid. Have you heard of solid? Right? Solid is an acronym of acronyms that was invented by Uncle Bob, which stands for, each of those letters stands for a principle. So solid is, the S is single responsibility, the O is open close, the L is list of, the I is interface segregation, and the D is dependency. It's been beaten to death, right? It gives me chills to put it on the side again. You can find so much information written about solid. But I'm going to mention a couple of them, not all of them, and some other things that I think are important when you are not only designing, but how to apply these principles as well. Not only what the principles are. This one, though, is very important. This is by far the most important principle, pretty much, in programming. And it comes, again, from a very, very, very simple and basic concept that goes back to the Roman days. Right? Divide and conquer. When I'm confronted with a program, with a problem, I try and split it up into smaller problems and then try and solve those problems, right? We do this constantly. Doesn't work in marriage, but in more other cases it does. And this is the same thing. What the single responsibility principle says is a class should only have one responsibility. It should only do one thing, right? That's simple enough to understand, no? I have a class, customers. It adds customers, it deletes customers. And why even deal with customers? Google Analytics. I have a class which is called import client, which by far, I don't know why the hell he even named it that. It was like, he started out with one class, and then he just left it there. It does everything that is relevant to Google Analytics. It's got one and only one responsibility, which is to deal with Google Analytics. So, he's complying to single responsibility. Of course he is. The problem is that his definition of responsibility isn't what the majority of people that understand the principle think of a responsibility. But what is that? I don't know. What is a responsibility? If I say I have a customer class, what does it do? It adds customers, deletes customers, prints customers, lists customers. Am I abiding by single responsibility? If my responsibility is to deal with customers, sure. The problem is that responsibility is very ambiguous. It's where do I draw the line of what a responsibility is? How do I define what a responsibility in my class is? Now, often when you read about SRP, one thing that people like to say or define is a class should only have one reason to change. Right? So if I take a class, I look at that class, and I see the reasons why that class needs to change. Take my Google Analytics class. What are the reasons for that to change? Well, it talks to a SQL database. Therefore, if I move away from SQL Server to Oracle, I would have to change it. It talks to the API of Google. Therefore, if the API of Google makes any changes to this API, I have to change that class. It does reporting, which means if the format in which I want the report outputted changes, I have to touch that class. And you say, fine. Big deal. At least I know where the class is. So what's the problem? Well, the problem is that what happens normally when we touch code? Someone told me? It breaks. And if we don't have unit tests, we get ulcers. Because we deploy things without testing. Because when we add new features or we change things, we normally check that well, there was one guy that never used it, but anyway, he was from the Canary Islands. What we did do is check what we've changed. If we add a new feature, we verify what we've changed. The problem is that normally what we've changed isn't the thing that's going to break, is it? It's something completely and utterly irrelevant that is someplace else in our system that breaks. I change one line of code here and it affects that line of code there. And on top of that, if we have these big classes, powerful classes, almighty classes that has a lot of things, what happens? That there are a lot of parts of the system that are talking to these classes. Therefore, if I change something in that class, it has a wider impact on the system. So, if I have one class with a lot of things, we have a problem. The other problem is that it's not readable. What is easier to read? That class with 1,000 lines or a class with 10 lines? I'll give you a hint. It's got 1 0. Right? Fine. So we say one way to do this is to think about a class and the reasons to change. And then we start to segregate that class into smaller classes so that each class only has one reason to change. So the import client, I will separate one out that talks to databases, one that actually does the report printing, one that does the formatting for the report printing, one that is an interface to the API, etc., etc. How many of you write methods in your classes? What is an object? An object is data and behavior. And yet, a lot of us do classes that are better named DTOs, data transfer objects, that have absolutely no behavior, or we do these classes that have absolutely no data, have no state, kind of act like a service. I just call values, right? But think about your other classes where you create methods. Do you pass parameters to your methods? Right? Take those parameters that you're passing to your methods and move them out from parameters to be instance fields. Okay? And then when you call the different methods, they rely on instance fields. See how many of those methods share instance fields. If out of 8 methods, only 2 are sharing instance fields, then there is low cohesion between those 2 methods and the other 6 methods. Maybe they don't belong in the same class. One of the things I like to say, if you use tools like Resharper or CodeRush or whatever you want, normally they give you a hint of this method could be made static because it doesn't use any instant fields. Sometimes you can take that as a hint of, hey, does this method actually belong in this class? Maybe I'm trying to get another class out of this. Methods aren't exempt. Single responsibility, when we talk about single responsibility, we normally always define it in terms of methods, in terms of classes. We say a class should only have one responsibility, a class should only have one reason to change. Here's a method call. If I can update, it's a Boolean, do something, else do something else. Give me one good reason why I should do that as opposed to write 2 methods. Why am I creating one method that does 2 things based on a Boolean value? Why? Let's forget about testability, because even if we are testing, it doesn't make any difference if I want to test 2 branches in one method or 2 methods. But why would I do that? And yet we do. Of course, we make this extensible, right? So what we do is instead of an bool, we pass in an enumerable. Right? And then we say, oh, switch. That's not good either. Or forget bools. We pass in some string and we say, if the string contains this, do this, else do that, else do this, else do that. What happens when we want to extend the program? We've got to touch the code. And then we get this if statements and the switches. And then the methods start to become big. A method should only do one thing. What should I name this method? Update customers if true, else exit. If your methods have ands, ors, maybes, sometimes, if you're feeling nice, it's a sign that maybe your method is doing too much. So you start to have to apply SRP to methods as well. And then you'll end up with small methods that do 1 or 2 things, 1 or 2 lines, 3, 4 lines, that's it. Right? Not with methods that have 50, 60 lines. The solution there isn't rock scroll. The solution there is to refactor that method and create smaller methods. What is the downside to that? Someone will say, optimization. That's a lot of calls. Yes, but I can guarantee you that your problem is going to probably be the database or your network connection before it is stack calls. So premature optimization, you've heard the saying, is the root of all evil.